Welcome to Chapter 1 of the NFV 101 course. This chapter is about NFV Basics. Before we talk about what NFV is and the basics of NFV, let's look at the challenges faced by service providers. This is based on multiple conversations with service providers where we found some common themes. The first challenge we are seeing is competition from over-the-top and web service providers. For example, it could be Netflix for video, it could be WhatsApp for messaging, or FaceTime for audio-video communication. These services are innovative, they create value for consumers and enterprises, and in turn, they're catching the fancy of end users. This is providing competition for service providers. The second challenge we are seeing is tremendous pressure on average revenue per user, or ARPU, where end users expect the price envelope to go down, or they expect more services to be provided in the same cost envelope. And the third major challenge is the need for agility to be able to provide network services to customers in an agile and dynamic fashion. While this might have been a nice to have previously, with 5G and edge computing, it is going to be absolutely mandatory. There's really no way to deliver services like network slicing or edge compute applications without a dynamic infrastructure and dynamic network services. So how do we solve these three challenges? Network functions virtualization, or NFV, is a critical part of the solution. It's a foundational technology that can solve these problems. Now, it's not the only technology, but it is one of the critical technologies. First, we'll look at how NFV impacts the network, and we'll sort of whet your appetite with NFV, and then we'll actually look at what it is. So on the top, it shows a very traditional cable network today. So on the left-hand side, you have users with CPE or cable modems. It could be also managed Wi-Fi, web UI is part of the mix. That goes to a remote PHY device that through a switch goes to a CCAP core. That again through a switch goes to a firewall, router, ultimately to internet connectivity. At the bottom we have how the network will be delivered in an NFV world. So on the left-hand side, you still have a CPE and cable modem. Services like a managed Wi-Fi and web UI, as you might notice, have moved. They're no longer at the in the device. They're not hard-coded in the device, but rather they're in the cloud, as we'll just look at in just a second. The cable modem or CPE connects to a remote PHY device, which connects to a switch that now goes to a virtual CCAP core, which consists of commodity servers, x86 or ARM servers, that are running VCMTS core software, virtual video core for linear programming, and virtual out-of-band core for sort of video on demand. That infrastructure connects to a switch that then goes to a router, and the services that were provided in the regional data center as hardware devices and some of the services provided at the customer premise in terms of fixed functions are now all provided as software. So in the regional data center, again, you see commodity servers, and you see things like managed Wi-Fi and web UI, which used to be on the customer premise equipment, and things that were in the regional data center like firewall are now virtualized into a virtual firewall. So this gives you a flavor of how NFV changes your network, makes it more dynamic, takes it into a software direction, and we'll talk about sort of the nuances and the benefits in a lot more detail as we go along. So now that you've seen what NFV can do, let's sort of back up. Let's talk about what NFV is. On the left-hand side, you see a traditional network. It consists of proprietary single-function boxes connected together over a physical network and connected to physical storage. So these network services are sort of manually constructed, and there's a lot of manual configuration and management as well. So that's what today looks like. in the world of NFV, the first thing you do is to virtualize all the physical resources. So these physical network functions are now virtual network functions running on virtual compute, virtual storage, and virtual networks, which then runs on physical hardware. Of course, you need physical hardware, and that physical hardware is commodity servers, industry standard, sort of x86 or ARM servers. Now, virtualization is only the first step. Beyond virtualization, next we want complete automation of network service deployment, provisioning, lifecycle management. And then beyond that, the next step is to not just automate network services, but to also automate the operations side of the house in terms of ops, service assurance, real-time closed-loop automation. So all of these things will move the operations mindset from a break-fix mentality to a plan-build mentality. This sort of talks about what we just discussed in a slightly different way, where again it makes the point that virtualization is only the first step. A lot of people confuse NFV with just virtualization, and while that is the first step, it's not the only step. So as this slide shows, the first step is virtualization, sort of lift and shift. But the next step is to go to cloud native. So cloud resources, so virtual compute, virtual storage, virtual networking, virtual network functions or VNFs, and entire network services will move to a cloud native architecture. And what that does is it provides a lot more automation at the network service and resource orchestration level. And then beyond that, you have autonomous networks where not only are resource and network services automated, but entire operations is automated through closed loop automation, automated service assurance, etc. So we have taken a very quick look at NFV. Now, how does NFV help? So NFV helps in three manners. First, it helps increase revenue. And it does this in many ways. First, it reduces the time to revenue. Because we are talking about software as opposed to in the pre-NFV era, it would have been designing chips, getting those chips fabricated, designing boards and getting them fabricated, getting final systems, boxes done based on those chips and boards, then writing software, then putting the whole thing into production. So we are talking about multi-year cycle. Now, if you need a new service, it's really just software running on commodity servers. It can be rolled out as quickly as you can write software. So that's the first thing. It reduces the time to revenue. Second, it makes it easier to trial and launch new services via software. I remember talking to a service provider several years ago about WhatsApp. The conversation was really interesting. The service provider knew that something like WhatsApp created value for their customers. They even saw WhatsApp as a really small company that had an interesting service, but they were not able to do anything about it. They didn't have an infrastructure where they could simply deploy a service like WhatsApp, roll it out to a small subset of their customers, and then based on the feedback, either kill it or iterate and refine it and roll it out to all of their customers. So the problem really wasn't lack of awareness, it was a lack of ability to implement. With NFV, this problem gets solved. You now have a dynamic, agile infrastructure to try out new services, roll them out to a subset of customers, iterate on them, and then roll it out to the entire customer base or to kill the service. New dynamic business models which previously were not possible, like on-demand pricing, spot pricing, auctioning off resources and bandwidth, those types of things were simply not possible previously. Now with NFV, all these new and interesting dynamic business models can be tried out. Next is improved customer satisfaction. The first one is self-service. So take an enterprise CPE experience. Today, the enterprise would have to call a salesperson, place a PO, have multiple meetings with a program manager involved and multiple other individuals from the operator side. And after weeks or months, they would get their service. In the NFV world, it could be self-service, where they just go to a portal, click on a few buttons, and get their service in literally minutes. So we are talking about a dramatic improvement in customer experience and therefore customer satisfaction. Try before you buy. This, if it had to be done in the physical world, a box would have to be shipped, the customer would have to try it out, and then if they didn't like it, they would have to package it all up and return it. Extremely painful experience. In the NFV world, it's just a piece of software. With a click of a button, you can authorize the user to try it out, and it expires automatically. Dynamic scaling, healing to maintain SLAs and resilience. With NFV, you get automatic scaling on if the demand for a network service goes up, it automatically scales up. If there are outages in cloud regions, there's automatic resilience and healing built in, which will maintain the SLAs for the customer in a variety of situations. So there's no more will you have to face congestion, no more will there be sort of regional outages that cause a service to go down. Again, improving customer satisfaction. Next, there will be a rich catalog of services. Because it's software, it's possible to have a lot more applications for the users that they can just go to a catalog and purchase as the need. It could be consumer services. Let's say they want parental control, or they want a different kind of firewall or whatever, they can just purchase it. And on the enterprise side, again, it could be a rich catalog, but what's more is it could be a catalog with multiple vendors. So if there are 5 flavors of firewall, now the choice of which firewall to choose now is on the consumer. They get more choice, happier customers. The third benefit is cost reduction. The first is commodity hardware. Commodity hardware, you get the benefit of servers that are used across enterprises, web scale, etc. So these are very, very high production servers, and therefore the costs are lower. Best-in-class software components. A lot of these software components are actually open source, and they've been used, and even if they're proprietary, they're used across enterprises. So for example, Linux or hypervisors. These have been used for years and years in the enterprise. They're hardened pieces of software. They cost less. They're easy to manage, driving down both OpEx and CapEx. Improved resource utilization. This is an important point. Previously, a network service was constructed for one use case, and let's say the utilization was low. Maybe at nighttime there weren't as many users. Well, there was not much that could be done. That service just lay idle, and those resources lay waste. Now it's possible to improve resource utilization by having multiple services share that piece of hardware. So for example, if again in this same example, if at nighttime a piece of hardware is experiencing low utilization, it can be used for something else. A new network service can be put on it just for that period and then removed when the traffic jumps up. Supply chain disaggregation is another way to get cost reduction. In the current world, the entire solution typically comes from one vendor. That vendor provides the hardware, the software, the systems integration. With NFV, it's possible to disaggregate the supply chain. Servers could come from one vendor. The infrastructure software could come from another. The VNFs, virtual network functions, could come from a third. And then system integration could come from yet another vendor. So it's possible to disaggregate the supply chain and in turn get efficiencies and save cost. Of course, it's not necessary to do that. It's still possible to use the traditional procurement model and just go to a one-stop shop and purchase software, hardware, system integration from one vendor.
But in this world of NFE, it is possible to disaggregate the supply chain. And last but not the least, automation of network service lifecycle management, resource lifecycle management, service assurance with operations automation will provide tremendous operational savings. In the next few slides, we'll look at some key NFE topics. We are going to look at these topics in more detail in subsequent chapters. So in this chapter, we are just introducing these topics at a real at a real high level, and then we'll go into more detail subsequently. So this talks about several of the NFE use cases. So on the left, you see on-premise. In the middle, you see edge and access. And on the right-hand side, you see cloud or core. So at the left, you have SD-WAN with virtual customer premise equipment for enterprise along with security, or virtual customer premise equipment residential with security. It could be a virtual cable modem, it could be a virtual set-top box, and the BRG here is just a generic term. It means bridge residential gateway. In the edge access, you have vCCAP core for cable customers, you have virtual OLT for fiber customers, and you have vRAN for mobile customers. Then you have MEC, which is multi-access edge computing applications, and it shows augmented reality and virtual reality in the slide, but that's just 2 out of dozens and dozens of applications ranging from tactile internet, education, virtual gaming, all kinds of applications. Then you have analytics and machine learning at the edge. For example, if you have video cameras, sending all these streams to the cloud or the core and doing image recognition there is simply not bandwidth efficient. It's a lot more efficient to do image recognition at the edge and just send a very low amount of data just on what faces were found to the core.
Then you have virtual CDN and video. Video is expected to get revolutionized. For example, if you're in a stadium, you will be able to see multiple camera angles. If you're at home, you'll be able to see 4K 360-degree video. Next, you have virtual provider edge. In the cloud or the core, you have virtual evolved packet core for mobile networks such as 4G LTE or 5G. And then you have virtual IP multimedia system for services such as voice over IP. Some of these terms are described below. They did not make it into the abbreviation section in the introduction deck, but you can review them here.
Next, let's shift gears. Let's talk about standards. ETSI has an industry standard group called NFV. So there's NFE ISG. ETSI took the lead on becoming the standards body for NFV. They really kicked off NFV in 2012 with an architecture white paper, which to this date is sort of the gold standard on NFV reference architecture. They're focused all the way from infrastructure to management and orchestration. There are over 300 member companies, 37 network operators, and the APIs and data models that the NFE ISG has developed are really the gold standard across the industry.
Next, let's talk about NFV and open source. Open source is a great way to complement open standards. It really provides a reference implementation of the standard and validates the standard. But over and above that, open source provides numerous other benefits. For example, faster innovation. Open source communities typically innovate at a rate faster than proprietary software, and it also allows for just about anybody to get involved, including the operator. So if an operator wants to sees that certain feature is not moving quickly enough, they can just jump in and start working on it. Ability to influence the roadmap. In the proprietary world, a CSP would have to talk to a salesperson who would then talk to a product manager who would then take all the feature requests they're getting from multiple customers, prioritize them, and provide them to engineering, and then who knows what gets done when. In an open source community, it's a lot easier to influence the roadmap because, again, it's simply your ability to influence an open source project depends on your involvement. The more involved you are, the more you can influence the roadmap. Open source provides for reduced lock-in. Typically, there are multiple vendors working on a successful or a vibrant open source project, and that reduces the chance of lock-in. And of course, the ultimate defense to lock-in is the ability for a CSP to do it yourself. They could just take the open source software and support themselves. And the last is transparency. An open source project is not just open in terms of the software, but also in terms of the process. The build process is open. The integration process is open. The testing process is open. How features get prioritized is open. So there's just tremendous transparency in an open source project. All right, let's shift gears a little bit. Let's talk about challenges to an organization in terms of implementing NFV. So transformation is definitely a cliche and overused term, but it actually applies here. NFV requires a transformation across multiple departments and organizational boundaries. So the first impact is on the org structure. It requires breaking down of silos and forming new roles and relationships. For example, dev and ops may have to work a lot more closely. Procurement and architecture may have to work much more closely. Product management and engineering may have to collaborate a lot closer on definition and ongoing definition of services. In terms of roles, operations may have to move from a break-fix mentality to a plan-build mentality. So these are just some of the ways that the organization gets impacted. Processes get impacted. For example, systems integration. As we talked earlier, a CSP can choose to become their own systems integrator. Of course, this has a huge impact on processes and the organization, but they could. Development has to move to an agile methodology. There's a broad impact to security practices, which we'll talk about in a lot more detail. Technology, we talked about some of the technologies that are going to be new, but the organization will have to gain familiarity with those technologies. There are going to be new interfaces. There's going to be new security technologies. So there's a lot of technology that has to be absorbed by the organization. Skills. There just aren't enough people in the industry that you can either recruit as employees or contractors to help out with the NFV transformation. So a lot of the skills have to be inculcated organically in-house. And that can come from training courses such as these, and knowledge transfer between groups. Business models are going to change, so the business team is going to be challenged to figure out new and innovative models such as on-demand, auction, spot, etc. Procurement is going to have to think differently. And not only is the disaggregated model going to present new challenges and opportunities, but software licensing, which again we'll talk about in more detail. New vendors popping up, new models, which we talked about. So these are all the ways an organization is going to get impacted. And by no means is this comprehensive, but these are sort of 6 broad areas that will be impacted. Next, let's shift gears. And as you noticed in this introduction, we are shifting gears a lot. We are jumping from topic to topic to give you an overview of a variety of topics that we'll look at in more detail in subsequent chapters. A sister technology to NFV is SDN, software-defined networking. And really, it's important in the whole sort of equation, and it complements NFV quite nicely.
So what is SDN? Previously, when you had switches, routers, gateways, etc., the control plane and the data plane used to reside in that one box. It was sort of a monolithic box, all encompassing in terms of its functionality. With SDN, the control plane gets separated from the data plane. So these boxes are lighter, simpler, easier to build, and all they take care of is the data plane. The control plane moves to a set of controllers that are centralized, and now this offers a variety of new and interesting capabilities. So first, the management of the entire network can be centralized, including VNF configuration, and we are talking about physical network and virtual network. So that provides a lot more efficiency, it provides a lot more control. We talked about SDN complementing NFE because NFE ultimately does require networks to connect these VNFs, and that's where SDN comes in. SDN can be fairly complex. You can have a global SDN controller that provides the plumbing between clouds. Then you can have a domain SDN controller that provides underlay network configuration and management, and then overlay or virtual network configuration and management. So multi-layer, multi-domain may require multiple SDN controllers. That's not uncommon. And this centralized control also opens up some security challenges that have to be addressed. In conclusion, NFE will be a key part of your future. It's not a question of if, it's more a question of when. NFE transformation is a journey. It's not something that can get done overnight. In fact, if you look at Netflix, it took Netflix 7 years to move to a complete cloud-native world. So from a traditional they started with traditional applications, and they moved to cloud-native. It took them 7 years, and of course, they're not done by any means. They keep evolving. So if it took a company like Netflix 7 years, we are talking about, here we are talking about a multi-year transformation. Standards and open source will both play a key role. It's not going to be just one or the other, but it's going to be both.